extremum is max min together. So in our picture, this is it, right? This is a max, isn't it? And that coordinate seems to be -1 and what is that thing? 15, right? Okay. You with me? And then this seems to be our minimum, which is 3. And, ooh, is it -17-ish? We'll calculate it later, but I think by just reading it off the graph, that seems to be what it is, right? Okay. The question is, can we get this without the graphing calculator? Right, with the Desmos over TI-84, this is pretty easy, right? But now you're in calculus, so we have to find the max min. This is the most applied area of calculus. Maximizing profit, minimizing the cost, and all that nice things, right? So first thing is, let's evaluate. So let's find f prime of x, eh? Let's see what that is. F prime of x, 3x squared minus 6x minus 9. Y'all agree? Okay, then looking at the graph, what do you notice about the value of this slope? It is flat right here, isn't it? Meaning this needs to be 0 at the extrema. Good. So we set this equal to 0. Let's not say it equal to 0 here. We set it equal to 0. Let's be professional in our presentation here. Well, is that too much algebra? Quadratic function? Let's factor it. 3 and then x, is it +1 and then x minus 3? Did I do that right?
Yes.
Oh, too much algebra? No? Okay. That tells you x is equal to -1 over, and you know it has to be over, right? X is equal to 3. And lo and behold, look at the x value in our extrema, -1 and 3. How about that? Okay. Now, don't do this on the test. Don't do this. I'm about to write something that will cost you a lot of points. I've seen this so many times. So that is like max -1, min 3. Does that even make sense to you? Shouldn't maximum be bigger than minimum? Like what is this? Okay, let's remember max min is a y value. Okay? So don't be just giving me x value and say that's a max min. Okay? And since we are pretending we cannot see this function, because really there will be a function that you cannot feel, we should still be able to figure this out with calculus alone. So back off on that hideous mistake. Now, to see is, let's just figure out the slope idea. Where is the slope positive? Here and here, isn't it? Meaning increasing. Do you see when the slope is positive, the function is increasing? And then hopefully you all know where this thing is increasing and it's decreasing here and the slope is negative, right? So not only we need to find the zeros of the derivative, but it comes down to this inequality. F prime of x, F prime of x, I want it to be positive and I want to solve this inequality. Okay, now that means this increasing, right? The function is increasing. Okay, on what interval? Now, do we know how to solve this inequality? This thingy, positive. Do you see the answer has to be -infinity to 1 union and then 3 infinity? Is that too much algebra? Do you remember last year? Inequalities? Yeah. You want me to show you how to solve it, or are we good? I need some kind of indicator. Time's running out. Okay, we can go. And then, of course, f prime of x, I want it to be negative, which means decreasing on, and then that needs to be between 1 and 3. Do you see that? Say yes. So what we have is function is now turning increasing to decreasing. Therefore, its maximum is right there. Let me push this thing down a little bit. Therefore, we can now say maximum, and watch the notation is f of 1. You get it? And I believe that's 15. And our minimum occurs where the function turns from decreasing to increasing, right? Decreasing to increasing. So therefore our minimum is f of 3, which is, I think I need to show you how to evaluate this. I plug in 3 here. Watch this. Do you still remember this trick? Oh yeah, that's why they taught it to you, right? 1, 3, 0, very nice. So we have -9, and that's -27, so -17 is predicted. How about that?
Isn't it -1?
Huh? Oh, -1, of course. Okay, the max min is the most applied technique in calculus. Because in a company, you have to maximize the profit, minimize the cost, and that kind of thing, right? So let's talk about what's local max and local min versus absolute max and absolute min, okay? So anything that looks like it, if you zoom in close enough, like this, yeah, that's your maximum. You know what I'm saying? That's locally max, also known as relative max. Okay, and then this part is a local max, right? In this picture, this is a local min, this is a local min, and this is a local min, assuming function exists at the endpoint. So far with me? That is a very easy definition. Now, among the maxima, the highest one, the winner, this one, right? This is the absolute max. Get it? But also a local. You know, the first contestants in a beauty pageant, they move on to the second round and they like that, right? And among minima, this, and that, the lowest one, this is the absolute minimum. Are we okay with all this terminology, definitions? These are just definitions. Now, here's an interesting question. What happens if this happens to be empty? This one got disqualified by failing the drug testing or something like that. Now, which is our winner? Which is our absolute minimum is the question. Should we give it to this one? Is this your absolute minimum? You might say, but, wait. What about a bunch of these guys? Right? Who did better than this one? You know what I'm saying? So like, okay, but then there are so many, infinitely many actually. Right? So what is your absolute minimum? You go back to that one? No, that one got disqualified. Right? You have to show up to win. So what is our answer? What is our absolute minimum. If that happens, we say there is no. No, that's right. God, my pen. No absolute min. You get it? It's okay to have no winner in a contest, but you cannot have multiple winners. You get it? You know that old saying in elementary school, everybody's a winner, right? That's just another way of saying nobody really won. Everybody's all special. That means nobody really is. How about that? It's not going to be part of our curriculum, but do you know what they call that thing in real analysis in college? This is known as infimum. It's not a minimum, but it's infimum. It's a lower bound. You get it? Okay, you don't need to know that for our curriculum, but you will just say absolute minimum does not exist. How's that? Good, good, good. I know, it's like we talked about delta function, jump at derivative of jump discontinuity, and then now there's that, right? Okay, within that context, let's read this, okay? Now let's just observe a couple of things. At this local max or min, derivative is, well, slope is flat, right? Or it could happen like this, which is pointy, which brings in the unnecessary painful memory from the past, but right? So at a max or min, the derivative is either 0 or non-existent, right? And these are known as critical points, which is defined by this, or this does not exist. You get it? And that gives us a nice place to look for max or min, because our job for a while is to find the maximum and minimum. Then you have to start somewhere, and critical point is really nice to start looking. Good. Secant graph looks like this. You are using cosine to graph this thing, right? So cosine looks like that. You know what I'm saying? So we would have vertical asymptote right here, right here, right here. So our secant will look like this and look like that. And this point is 0, 1, and this point right there is, that one is 3 pi over 2, eh? 3 pi over 2? No. What is that point right there? Pi, right? Pi and negative 1. So that is within this domain. So this thing exists from here all the way to there, right? Okay, so we can tell by graph, but how can we do this without graphing is the question now, isn't it? Okay, first of all, we take a derivative. So g prime of x is equal to, is it secant x and tangent x? Good. Now you set it equal to 0 to find the critical point. Because you notice the graph right here, you see it's flat right here and it's flat right there, isn't it? So that's the key. If there's a max or min, either it will be flat or it will be pointy like this. You know what I'm saying? That's still minimum. I know it brings out the painful memory, but still that's the minimum nevertheless. So we set it equal to 0 or we look for the place that is undefined, right? So this is 0 at 0, x is equal to 0, and also x is equal to pi, correct? Can we do this, or do I have to Do you want me to show you how to solve it, or can you just do this by looking at it? This is never equal to 0, so it's where tangent is equal to 0, and tangent is 0 at 0 and pi. You get it? Say yes. No.
Yes.
Yes.
Okay, then this is my requirement. There are many different teachers and many different tutors actually do it with a chart like this and 0, pi, and pluses and minuses, and right. Unfortunately, AP does not accept this as showing you enough of your work, so I cannot accept this either. This is the only format that will be acceptable, and no other format is acceptable. So if you have a tutor that tells you otherwise, fire that tutor today. Okay, this is my format that is required to all of you. Okay, this means increasing, right? Right.
Yep.
And then I also want to do this. On, I want to say on, here, let's do. And then G prime of X is negative, that means decreasing. On, okay. Now, secant times tangent, we have no idea what this thing looks like, right? I forgot one thing, and I'm gonna insert it in the middle, and I advise you to do this one first. That messed up my graph. Hold on. Okay, I advise you to do this one first, because critical point is where this thing is not only equal to 0, but undefined, right? So we actually have to do this. G prime of X is undefined. At X is equal to. Now we are looking for the vertical asymptote of both of these things, but don't they have the vertical asymptote exactly at the same place, right? Negative pi over 2, that's the endpoint, so we don't have to really consider it, but I will just write it anyway. Negative pi over 2 and pi over 2. You know what I'm saying? And then 3 pi over 2, of course. And this could well turn out to be the max or min. At least it plays a role here, okay, in solving this inequality. You with me so far? Okay, then. Yep. Now let's solve this inequality. Okay, let's try to remember back into pre-calc. How did we solve inequality? Number one way is by graphing. But this is too complicated to graph, right? Then how else did we solve it? Do you remember this tactic? Throw a line and you plot all the points. Well, now we know it as a critical points. Okay, so we'll plot it as critical point. Let's put 0 here. And then, so this is 0 and this is 3 pi over 2. And we need pi over 2 here. And pi right here. And 3 pi over 2. Now we plug in points, because we don't have to plug in these points. Either it's 0 or it's a vertical asymptote now, isn't it? Now we plug in points to see whether this thing is positive or negative, eh? Okay, let's plug in, the first quadrant. First quadrant, both of these are positive, eh? So we'll have positive here, which means it's increasing. And let's look at the second quadrant. In second quadrant, both of these are negative, correct? Which means it's increasing again. What's going on? That's why having a graph is critical. You see, increasing and increasing. You know what I'm saying? You know what I'm saying? There's a vertical asymptote,
Yep.
that's what's throwing you. Okay, in third quadrant, this is positive, this is negative, so we have negative. You know what I'm saying? That means it's decreasing. You see right there, it's decreasing. Okay, let's look at fourth quadrant. Fourth quadrant, secant is positive, tangent is negative, so we have negative. You see it's negative down here. So this thingy describes this graph. Good. I know this is nice and convenient, and your textbook does this similar thing too. This is not good enough. You can have it on the test page. I wouldn't deduct points for having it. This is not showing enough work. You know what I'm saying? So we still have to answer the question in the proper format. So it is increasing here to here. So we have to say on 0 to pi over 2, union, taking out the vertical asymptote, of course, and then pi over 2 to pi, and decreasing on pi over 2 to 0, union that with pi to 3 pi over 2. Did I write 3 pi over 2 here? I mean negative pi over 2. Negative pi over 2. This was negative pi over 2. So far so good, but it's more convenient to look at this thingy right here to tell the maximum or minimum. Do you see right here, decreasing followed by increasing? This has to be a minimum, right? Let's see. See, decreasing followed by the increasing constitutes a max minimum, right? This is we have to know better from our original function. This is a vertical asymptote, so it's never max nor min. This disqualifies. And then right here, increasing and decreasing, that's a max. You with me? Right, but all of this, really you can get it out of this too, but this is a little more convenient, organized thoughts. So now I can say, therefore, I can say max, excuse me, don't say just the x value. Okay, max min is a y value, so we have to say it like this. And then pi negative is equal to -1. And then minimum 0 just equal to 1. I know this looks a little weird because your max is greater than your min, but understanding the graph with a vertical asymptote, this thing is a weird curve. Okay, that is like one simple thing that you can feel is this complex, huh? Oh my God, right? Okay, question before I move on. Moving on. This
Yeah,
thing
Mr. Kian, so in this case, do you still consider that they are the absolute maximum or they're just the local?
No, there's no absolute. It's only local. Because let's think about it. This, if you think about this an absolute maximum, this point is a lot higher. You know what I'm saying? Absolute maximum of all. And this thing reaches up to infinity. So there's no absolute max or absolute min.
Okay, so in that case, we just stay the local ones.
Absolute maximum has to be the highest y value within this interval, whatever the domain that you're given.
Understood. Thank you so much.
Okay, now, so let's talk about this then, huh? This is slightly easier if you write it like this. Good. And let's take a derivative. Y prime is equal to -1/2 and 1 minus x squared to -3/2. Now deduct -2xa. Some of you forgot this on the test. Okay, let's convert it back. This thing, 2's cancel, negatives cancel, so you have x on the top, 1 minus x squared, 3/2 here, right? Okay, let's look at the critical points. Critical points. I should have called it critical points earlier. And of course, there's like you can set it equal to 0, but I want you to look for the vertical asymptotes first. Because if you set it equal to solve it. Vertical asymptotes are quicker. After you solve it, this one is easier to solve. But after you solve it, you tend to forget these things. So this, let's do this first. When denominator is equal to 0, x is equal to plus or minus 1a. My computer is frozen. X is equal to plus or minus 1a. And then, of course, x is equal to 0. Do you remember last year, whenever you're doing inequality of this, she made you say like, well, whatever that makes numerator 0 and denominator 0? Yeah, this is like critical point thing. Except she didn't want to say critical point because you're not in calculus yet, so you don't know that vocab yet. You know what I'm saying?
She said critical points every day. She kept telling us critical points.
Use that point. Oh, so this thing is a smooth transition now, right? Wow, foresight then, huh? Oh, okay, I was kind of assuming that she didn't use that calculus vocab, but hey, critical points. So it says critical points, and that's why these points are critical, because that might be your max or min. Good. Okay, and now, but then you also have to realize the domain of this function, even if they don't tell you, this has to be negative 1 to 1, right? So don't be looking for, notice that on in this thing, I really did not calculate the points outside of these two, because that's way beyond our domain that we are given. Do not consider anything that's outside of your domain. You get it? Okay, then we only have, so this point, and this point to consider, right? Say yes. You notice that denominator is always positive? Right? So, oh my God, this is easy then, huh? This is negative, this is positive, eh? Decreasing, increasing, eh? That's it. All righty, that's easy. Our job just got a lot easier. So we say g prime of x. Did I forget to write x here? What is wrong with me today? G prime of x is positive or negative. You want to do negative first? Yeah, let's do negative first.
Mr. Kim, it was y, not g.
Oh my God, I get confused my own handwriting, huh? That's why I didn't put, pardon me, y prime is less than 0, which means decreasing on here -1 to 0, right? And y prime is positive, which means increasing on 0 to 1. This is only format that is acceptable, okay? So when we have decreasing followed by the increasing, this is your minimum, isn't it? So therefore, this one is absolute minimum, isn't it? Local and absolute. Because the only thing this function does is decrease, then increase. So this has to be like parabola at the bottom kind of thing. Absolute minimum at f of 0. And you plug in 0 and you get 1. How about that? Good. Say yes. Okay, moving on.
Yep.
Yeah.
Wait,
Now,
Mr.
yes,
Kim,
Yes.
to know the absolute minimum, like,
It has to be the lowest point in its existence. So if you don't know what it looks like, then you start picturing idea. It's decreasing followed by increasing, and that's all it does. You'll probably think this is a parabola. Well, like that's your absolute minimum, right? Yeah,
Okay,
that's how. If there's a vertical asymptote, then that might throw everything off, right? But there is a vertical asymptote, but this is not like secant graph, right? It doesn't exist across the vertical. You see, if there's a vertical asymptote, then this might happen. Then you don't know whether this is absolute maximum or not. You know what I'm saying? So you have to be a little more careful, plot view points if you have to. But in this case, it's only one piece, so we don't have to worry about it. How's that? So you still have to feel the graph, okay? This one is very difficult to find the derivative now, isn't it? We could, but we need to modify this, okay? Let's change this f into piecewise function. Because you know you can always change your absolute value into piecewise function. You know what I'm saying? However, where are the breaking points? This thing bends at positive 2. This thing will bend at negative 3, right? So I want to have those 3. And it's easier to think if you start from the middle. So x is between negative 3 and positive 2. Now, where do you want to throw the equal sign? One on the left or one on the right? It doesn't matter to us because this is continuous. One on the left, it is. Okay, now this one, x is then greater than or equal to 2. And this one will say x is less than negative 3. How about that? Good? You with me?
Yep.
Now, it's easier. I'm going to need a little more space. I'm going to move that to the right. Oh, I love this OneNote. Now, if x is more than 2, this is positive and this is positive. So you can just write x minus 2 plus x plus 3, right? And that is 2x plus 1. You with me? And then you graph that piece, which is that one. You know what I'm saying? Just this part. Now, in the middle, if x is less than 2, this thing becomes negative, this thing becomes positive. So negative 1, you can always write it like this to make it absolute value, right? You know what I'm saying? And there, x is canceled, so you get 5. So that's this constant function 5. Say yes. And then when x is less than negative 3, then both of them are negative. So we have to put negative sign in front of both of them. So that becomes negative 2x and still plus 1, right? And that's got to be this piece. Did I meant 3 here. Oh, wait, it's minus 1. This is minus 1. This one doesn't really. If I am careful about it, yeah, it goes to minus 1. You get it? Now, we know what it looks like, so we know what minimum is, right? You still want to take a derivative? We could if you want to. Let's take a derivative. F prime of x, of course, is negative 2, 0, positive 2a.
Yep.
Oh, so we have decreasing, flat, increasing. You know what I'm saying? So we can still say it's minimum there. You get it? But we cannot really specify the x value because this is an interval. So we'll just conveniently say absolute minimum, which is without the x value, we'll just say 5. And how do I say at? That equal sign will concern you, but it's a technicality. I don't think AP will penalize you if you don't put equal sign, but it has to be equal sign both ways. In this, you can kind of, one of these days, today I don't have time, but you can justify it's the same point, so it's like you have to throw it in. There is a more bigger reason. So far, so good? Okay. We'll never get to the lesson or the test. Oh, okay, I'll still talk about the test. Now, this one, first thing we have to do is check the continuity. Why am I worried about the continuity? Because suppose this thing discontinues like this. Then is that minimum? Is this maximum? I mean, that creates a lot of unnecessary headache. You know what I'm saying? But luckily, this is continuous, so we don't have to worry about it. But we still have to check the continuity. You know what I'm saying? So let's say limit of y as x approaches 1 from the left, and I'll do this fast, just cheat looking at the graph, is 3. And then limit of y x approaching 1 from the right-hand side is equal to 3. Therefore, this function is continuous. You get it? It's continuous everywhere because that's the only point we have to worry about. Otherwise, polynomials are always continuous. You with me? And then we take a derivative. So this one will be negative 1/2 x minus 1/2 a on this piece. And this one will be 3x squared minus 12x plus 8 on this piece. Good. And this one does not have any vertical asymptote, but there is still critical point. Critical points are, what is the first critical point? It's right here. Why is that critical point? Because that thingy may not be smooth. You know what I'm saying? And in fact, if I plug in 1 here, and if I plug in 1 here, I don't get the same thing. So this, you get it? So it's pointy. It's not that pointy, but it's somewhat pointy. And derivative doesn't exist here. Left derivative and right derivative don't agree. Did I write 0 there? That's 1. So critical point is x is equal to 1. Let's just, before we forget, let's just get that one out of the way, right? And then the other one is whatever makes this thing is 0, right? Is that negative 1? Yeah, sure. See, negative 1, we have a maximum. So x is equal to negative 1. And then we'll solve this quadratics. Okay, so if we divide both sides by 3, so we have x squared minus 4. We cannot divide both sides by 3. Ah, that's too bad. So we have 3x minus, and then x, is it 24? No.
I don't think it is factorable. Like
It's not factorable?
I think you had it in the Dropbox notes, and it was like you had to use a quadratic formula.
Okay, so can you look it up and tell me what that is?
That's 6 plus or minus 2
6?
root.
6 minus 2 root
Root 3.
3 over?
Root 3 plus or minus.
This is plus or minus. Okay. Okay, now let's think about the negative sign. I'm worried about if this is minus, does it go below 1? Can somebody punch this into a calculator? If it's minus, it goes below 1, doesn't it?
Yeah.
Then it doesn't exist, so we only have to consider the plus sign. You know what I'm saying? You see, we cannot, this piece doesn't even exist beyond this line to the left. It only exists on the right-hand side. Okay, then now we do the usual thing. So we say y prime is positive, meaning this is increasing on. Now, let's just think about it. We can still do this, right? Let's say this is -1, and this is 1, and this is 6 plus 2 root 3 over 3, right? And this time we have to look at this interval outside. In order to save time, I'm going to do it fast. This will be positive, this will be negative, and this will be negative, and this will be positive eventually, right? So what we have is, this is your maximum, and that's nothing, and this is your minimum. You get it? So we can say this is increasing on negative infinity to -1, and union that with 6 plus 2 root 3 over 3 and infinity, and y prime is negative, which means decreasing, on, and that's between -1. Technically, we have to take this 1 out because derivative fails to exist right there. You know what I'm saying? And then 1. And there's a whole lot of other issues that arise from this definition of increasing function. I'm going to talk about it tomorrow or some other day if time permits. There's a whole lot of headache that I'm not really telling you right now. Okay? We can say, therefore, max, this is local because this thing extends up to infinity at -1. If you plug in -1, what do you get? 4. And then minimum f of that ugly thingy. And what do you get? This one, we have to punch it in the calculator, right? Does anybody have it? Okay, we'll just say you punch it in the calculator. How's that? Okay, right? Let's just try to feel it. If you can feel it, that gives you decisive edge. And we show our work to justify our feelings. So let me just think about this. If you have to graph x to the 1/5 power before we get to 2/5, let's just try to feel 1/5. Does that make sense to you? Because this is an inverse function of x to the 5th power. Does that make sense now? Because x to the 5th, we're like, so far so good. Now we are going to square it. That's what 2/5 power is. This thing is square. Do you see this was an odd function and it will convert into an even function now? Feel it? If you can feel this, there's your minimum right there. And this actually will extend all the way down to 0. This is a limitation of this computer. You know what I'm saying? Maybe if I delete and graph it again, it'll show you. I won't. Okay? Alrighty. Because if you plug in 0, it's got to be 0, right? Okay, I'm going to save this in the notes. So even if you don't have to do a decimals, I want you to at least decimals these things so that you can feel it with me. Okay, right there. Okay, now let's analyze it. So we take f prime and that is 2/5 here, x to the -3/5 power. So far so good. Now here's the most common mistake. If you just set it equal to 0, then there's no solution, right? Because this thing really is 2 over 5 x to the 3 over 5 power now, isn't it? However, what was the definition of critical point? Definition of critical point is either the derivative is equal to 0 or does not exist, right? And when denominator is 0, this thing does not exist, right? So this is still critical points. Remember Miss Flattery last year? She said critical points all over the place. That means either when you have these rational functions, numerator is equal to 0 or denominator is equal to 0. You know what I'm saying? Yeah, there's that. So there's only one critical point. Then do you remember this thingy? And then pluses and minus. If you put positive number, this becomes positive, so that means it's increasing. If you put negative number and it becomes negative, so it's decreasing. You know what I'm saying? So this must be our minimum then, eh? As you can see right there as well. Okay, good, right? Unfortunately, AP does not consider this as showing enough work. So I cannot take this either. That's too bad, right? So this is my requirement and nothing else will be allowed. I'll take massive amount of points. Let's say f of x is, do you want to do positive? Let's do it from the left-hand side, negative. That means decreasing. Can you feel it? Negative slope means decreasing from here. It's decreasing, right? Okay, on negative infinity to 0 here. And then, that's x right here. F of x is positive, that means increasing. On from 0 to infinity. How about that? Therefore, now we can say, this is absolute minimum, by the way, right? And you put 0, and then you get 0. How about that? That's complete work. Any questions before I move on to 37?
Do we need a test point in order to know the change of slope? Or? If
you wrote down the correct sign, then I will assume you tested the point correctly. How's that? You don't have to show me like putting in 1 and then like, come on, at this level, I'm going to assume you know how to do that. And if you screw up, then there's no partial credit of plugging in 1 the wrong way. Right? It's like, come on, right?
And is testing point like the only method of?
If it's polynomial, there's a graphing method. If you can picture the graph of this, then you can also use the graph to figure out positive negativeness. But as you can see in this case, it's not that obvious or easy to see it, right? I mean, if we feel the graph, that's the best way, but that's not justifying your work, right? You have to justify using calculus. Good. All of this work is to justify our feelings. We know what this thing looks like. You know what I'm saying? Okay, within that spirit, let's try to feel this. How many of you can feel this graph? Right, okay, let's go and do this. So if I graph, let's just do square root of, was it 4 minus x squared? I know there was an x in between, x in front, but let's just do this first. Do you at least feel semicircle? Oh, come on, we have done this before, right? If you square both sides, I think it's circle. So it's a semicircle upper half. This is an even function. Now we are going to multiply this by an odd function, right? Which looks like this. So even times odd. I'm not talking about even number times odd number, right? I'm talking about even function times odd function. What would that be? This is positive, and times positive will remain positive. This side, positive times negative, will be negative somewhere here, right? Right? So this thing should be an odd function, right? Okay, here we go. I'm going to put x in front of it. Feel it? right? It has to go through this point because there was a line, 0 times anything. And this point was 0, this point was 0, so wow, how about that? That's amazing now, isn't it? Yeah, I'm going to copy this into your notes. Okay, now we are here. Whoa, why does everything show up so big on this whenever I paste it? Okay. Now let's try to do this. This is very ugly. I'm gonna need a lot more room. But it's not like we are finding the second derivative, so that's maybe first derivative. So this is x times 4 minus x squared to the 1/2 power uv product rule. So u prime 1 times that, right? Plus u times derivative of the second one is 1/2 4 minus x squared negative 1/2 power, and just like on the test, many of you forgot this one, right? Okay, let's rewrite it. So this is square root of 4 minus x squared. I mean, nothing's wrong with leaving it with 1/2 power. To me, they look identical, but many of you have trouble seeing it, so I'm putting it into square root form. So it's going to be minus, and 2's cancel, so we have x squared over square root of 4 minus x squared, right? I mean, this is nice and all, but to test points, this is very ugly, right? I rather want to find the common denominator. Common denominator, of course, is this. It's a very good technique. So I multiply that thing here, so I have 4 minus x squared minus x squared, eh? Say yes. Okay, that's just 4 minus 2x squared, isn't it? Now I can talk about critical points, right? Okay. Critical points. If you have to go to next class, you may leave. Critical points. Let's look at the denominator first, because if you set that to equal to 0 and solve it, you'll forget. So denominator. Do you see x is equal to plus or minus 2 is a critical point? But, do you also see that's the endpoint in the domain? Oh yeah, huh? So we are not going to test anything outside of this. You have to domain and range is critical here. And also, x is equal to plus or minus square root 2, right? For the numerator equaling 0. Too much algebra? And that's this one. This is square root 2. And this one is negative square root 2. How about that? You good? Now let's test points, shall we? So this is the endpoint. And let's say this is ugly. Let's say here. This is root 2 and this is negative root 2. Okay? And we are not going to test anything outside. If you plug in 0 here, this is positive, eh? So we have positive here. If you plug in anything close to 2, you see we get negative. And then you get negative here as well. And obviously we are not going to test this outside because that function doesn't exist. So you cannot really test it. So what we see here is this must be our maximum, which is same thing as that one right there. And this must be our minimum, which is same thing as that one right there. How about that? Good? Okay, you may go. Let's present. Therefore, we can say y prime is positive, which means increasing interval on, can say from, it's hard to say, but I'll just throw it as this. Endpoint, does the derivative exist on the endpoint? Depends on what your definition of derivative is. I'll take it either way, from -2 to -√2, union that with, this is parenthesis, √2 and 2. And then you can say y prime is less than decreasing, here, right? On from -2 to -√2 to +√2. Therefore, we can say our max, in this case it's absolute, but is f of √2, which will be, if we plug in 2, right? And then min at f of -√2, and that gives you -2. How about that? This format only, no other format will be accepted. Okay, it changes the sign, derivative changes sign, derivative goes from positive, none of that is acceptable. This is it. Okay.